This is the podcast for Physical Science 8th grade, 3.4, Describing and Measuring Work and Energy. So what is work? Remember that force is necessary to do work. In order for work to be done, you have to exert a force on an object and it has to move. When work is done, it means that a transfer of energy occurs. And that transfer of energy causes the thing to move. Remember how to calculate work. Remember, in order to calculate work, you need to know the formula that work equals force times distance, or W equals FD. The force needed to lift times the amount of distance needed will give you the work required. I'm not going to ask you to actually calculate work, but you do need to understand the concept. In the scenario we have here, where we've got the 450 newtons to a height of 2 meters, we come out with 900 joules. What would happen, though, if we were to double the distance? What does that change in our final results? Again, make sure that you really know how this formula works and be able to apply it to a couple of different scenarios. Remember that work is the transfer of energy. Remember that when you do work on an object, some of your energy is going to transfer to that object. For instance, if you remember this picture of the dunk tank, so when this boy takes the ball, he's converting his energy from the form of energy that is inside him into another form when he uses his muscles to toss the ball. So you can think of them as a system or a group of objects, and they affect one another. Energy can be transferred from the boy to the ball, but the total amount of energy in that system does not change. Remember what potential and kinetic energy are. Potential energy means the energy that something has the possibility of doing something. For instance, gravitational potential energy is based upon how high something is off the ground. Kinetic energy is the energy of motion. So any moving object has kinetic energy. The faster it moves, the more kinetic energy it has. Calculating kinetic energy requires that you know its mass and the velocity of an item. Remember that the formula for kinetic energy is 1/2 of mass times velocity squared. In this scenario, we're going to look at a girl, and her mass is 40 kilograms, and she has a velocity of 3 meters per second. So we're going to put those into our formula, and we're going to take 1/2 of 40 kilograms times 3 meters per second squared. So remember how to calculate that and what that really does for the entirety of kinetic energy. If we put those numbers in here, you'll notice that they come out to where we have 180 kilograms per meters per second squared, which is actually 180 joules. What do you think would happen if we were to double the mass of the girl? And now let's make her a woman, and now she's 80 kilograms. What would happen to this kinetic energy? If we double it, now we have to put in 80 kilograms instead of 40, and then our calculations are going to come out to be twice that of what we originally had. This is an image of a freestyle skier in various moments of a jump. Where within this jump does his energy change? Where is it that they have potential energy, and where is it that they have kinetic energy? Remember that he has both. When you look at this picture, there is both happening here, because here at the beginning of the jump, he has kinetic energy because he's skiing into the jump, and he has a bit of potential, but not much. As he gets higher, his potential energy is going to grow because of that gravitational potential energy, and he still has movement going, so he has kinetic energy. So throughout this, he has kinetic energy going because he's constant motion, and his potential energy changes, but he still has it there. This is an image of a pendulum. A pendulum swings back and forth, and as it swings back and forth, it slows down. But where does that energy go? We know that that energy is actually released in heat because of friction with air. This typically happens with many different items. When they move, they actually lose some of their energy to other forms. Could be friction as something is rolling across the ground. It could be friction as something is swinging in the air. There's many different things that can cause this to happen, but friction is what causes that energy loss. As always, good luck on the test.